Hello learners, welcome to TryLite. Today we will be learning about synchronization. So in general sense we know what synchronization stands for. So we're here in Java also, when multiple threads access a shared resource, simultaneously the act becomes unpredictable. This is a race condition. This is a race condition, and coming on to this race conditions, we have a race condition occurs when two or more threads read that are made to read and write shared data at the same time, and the result depends on timing. The result depends upon timing, that one thread is completed, other thread is working, or likewise, and finally leading to inconsistent behavior. Yeah. Now, suppose for we have two threads which are uh, updating the bank balance of the program, updating the bank balance, and suppose two threads. So one thread can work upon the transactions, that is suppose room rent bill, and other will be deducting increasing the transactions for suppose there was a balance amount which was included in the account. So depending upon this, there are two threads acting upon here, and one is trying to update the account balance. Now here, for example, we have the synchronized account. Yeah, it's the class counter. Here it's a synchronized account, class counter. In the initial field is count equals 0. The initial field count is equal to counts is specified by 0. And we have increment method there. We have a public void increment, which will increase the count plus increment in the count. The multiple thread calling increment, there are multiple threads which is calling this method. There can be multiple threads. They are calling the method increment. Increment may override values and cause incorrect results. This may override the values and similarly may cause incorrect results. Now the synchronized keywords. There can be a synchronized keyword which makes the things arranged in a way. This is the way this synchronized keyword helps us. Now the synchronized methods. Now synchronized method also stands here, and the class counter. Suppose here is a class counter. The initial field count is 0, initialized by 0, and we have a synchronized public synchronized. This is a synchronized method. So synchronized void increment count plus plus. This will increase the increment as count plus plus. The initial field was 0, initialized by 0, and it will increase count plus plus. This will be increment in the count. And finally, closing the braces, it will lock the entire method. This synchronized keyword, it will lock the entire method. It will lock the entire method. No one can intervene into it, or nothing can be done to it. Only one thread at a time. Only one thread can intervene into a time at a time and execute it for a given object. So here it's locked. So no other methods can other methods can try to intervene into it, and only one method can finally execute on it. Yeah. Now coming to the synchronized blocks. Suppose there is a class counter with initial field count which is initialized with 0 value. Now object lock. We have performed the lock of that object lock by the name of lock with this new keyword, and there is object. Yeah, it's a class object. And suppose there is a method increment here. Yeah, which is synchronized with the lock parameter. So synchronized with the lock parameter. Lock as the object which we made here, which passed into here, and there will be count plus, but there will increment in count. Yeah. So coming here, it's more flexible. This synchronized method is more flexible. They can be synchronized only critical selections. They can synchronize only critical selections for particular selections or critical selections. If the value can be synchronized for that value only. Now coming to the coming further, we are able to see that without we are able to see the without and with synchronization method here. Without synchronization, suppose there is a class counter. It's a class, and with an initial field count initialized with value 0, and method increment plus plus. Increment having the body part as count plus plus. The count will increase, the value of count will increase here. Suppose for example we have a public class demo. We have a demo class here, which has the main method line, main method line which throws uninterrupted interrupted exceptions. Sorry, interrupted, which will throw interrupted exceptions. Now we are making a object of this counter. Counter equals new counter. Yeah, object of this counter with the help of this new keyword. And suppose there is a thread T1. Thread T1 with the help of this new thread. With the help of this new thread. Yeah, thread T1 equals new thread. Yeah. Now it has the body part for loop. It will go from 0 to less than 10,000, less than 10,000. And the counter increment and the counter count this counter, which was the object form for this counter, which is dot increment. We'll call the increment value for this counter. Yeah, so for this counter, each has an increment method, and we will call this increment method here with the help of the object form for this counter. Yeah. Now coming further, we have the thread T2. Thread T2 equals new thread, which has the function of yeah, this one counter. If we have done this, and now there is, suppose this was thread T1 and this one is thread T2, and suppose there is a body part here which says that for in initialization part, this loop will go from 0 to less than 1,000, 10,000 only. And here also we will increase, we will call this increment method of that counter class, or the counter class only. Yeah. So T1 dot start and T2 dot start, these are the methods to start that class methods. These are the lines to start the methods. And T1 dot T1 join, T1 dot join, and T2 dot join will help us performing the operations in them. And system dot finally we will be printing a line, system dot print final find with message final count plus counter dot counter, which was the object form, and for that count object will be count field will be created there. And we will be getting likely less than 2,000. So we will be getting 1,000, 2,000, less than 2,000. Now coming with synchronization. Synchronization also can be helpful. Likewise, we here see that make increment. Make increment was the method. Make increment is the method. Synchronized. It is synchronized with the output of 1,000 consistent. It is 20,000. Yeah. Now the output is consistent and it is 1,000. Now here we get the consistent output, and it is equals to 20,000. Here it is likely less than 20,000. Here the value is likely less than 20,000, and the here inconsistent, the value is only 20,000. That is likely is consistent 20,000. Now coming to the static synchronization. Public is synchronization static void. This is the main method line. Void with main method with method. Not the main method line. Is public synchronized. It is a synchronized static void. This is synchronized static void method. Synchronized method, which has a lock on the class, which will produce a lock on the class. Locks on the objects class. Yeah, the class name dot class instead of instance. Locks are the class object. It puts a locks on the class object instead of instances. It puts a locks on the class objects class instead. Is the class objects that belongs to the classes. It puts a lock on them instead of the instances that is they are acquiring. And they are useful when static variables are shared across threads. They are useful when static variables are shared across the threads. Now coming further, we have the inter-thread communications with wait and notify. Yeah. Now coming to the class shared, we have the shared class here. We have the shared class here shared. Which is synchronized void print event, which is a method, synchronized method, which throws interrupted exceptions. Now it will wait. Here there is a wait method, which will notify it will wait until notify is called. This method will wait until the notification is called. Notify method is called until the notify method is called. Until a notification is provided to it. Till that time, this method will allow the classes to wait from performing executions. Similarly, there is a println line system.out.println even. This will be giving the even number of times. Now synchronize with print odd. There is other method synchronize with method odd, which has a println which has a println line like system.out.println odd. This will here it will notify that the wait method can be is allowed to wait or can run. Yeah, here we have the notify method, which will allow, which will notify that the wait method can is allowed to stop or resume the thread. Yeah, here resume waiting thread. Yeah, here we have the line resume waiting thread. Now coming to this wait, this thread gives up monitor and waits. This thread gives up monitor. It will totally stop its functioning of the function or method in that particular block. Yeah, this thread, this will allow the particular block or class to stop its function, and ask the monitor to wait. And not this notify, it wakes up one waiting thread. It wakes up one waiting thread, which will allow one waiting thread to wake up and perform its executions and notify all. It will makes all not all waiting threads to be notified to work and execute restart. This wait thread will make the thread to wait, and this notify will allow to wake up the thread, and this notify all will allow the performance of all the threads in that function. Yeah. Now coming further, we have the common mistakes as we should perform, and there are some little suggestions also not to avoid them. So as to avoid synchronize not only critical is only critical sections. Synchronizes only critical sections. Synchronize keyword synchronizes only critical sections, not the whole method. It will not synchronize the whole method. It will avoid nested synchronizations to prevent deadlocks. It will avoid nested synchronization to prevent the deadlocks. Yeah. Now use higher level concurrency. It will use higher level concurrency tool like a rentrant lock and retrant lock and semaphore and concurrent hash map for complex classes. The higher level concurrency method tools are these, and for complex cases. Now, the common mistakes that we generally come across, these are synchronizing unnecessarily large blocks. We cannot synchronize. We should be synchronized, not synchronizing the large blocks, because there can be various functions which can be intervening into our programs and particular thread and performing a number of multiplications, a number of and performing multiple tasks on that. So we should synchronize. We should These are the mistakes that we shouldn't be synchronizing. We shouldn't be synchronizing large blocks. And coming to this, for coming further, we have the incorrect log blocks. We have the incorrect log objects. We should be performing correct log objects, as using performing of these log objects can stop object to stop executions without the other. Yeah, without performing the other tasks. Yeah. Now, forgetting to handle interrupted executions with wait. We are forgetting to handle the interrupted executions with this wait. This is always allowed us. This will always specify to us that when wait is there should be interrupted exceptions in accordance with that. Now we are coming to the end. We will meet in the next class. Thanks.